Welcome to Ganita Samayaha, an interactive learning space. Children, as I proceed with my teaching, whenever I pose in questions, please answer them. This will help you in the learning process. Also, please don't forget to have the writing materials with you whenever you watch these videos. And after you watch, please don't forget to subscribe, like and share these videos. Today, we continue with real numbers part 4. So in the last video, there was an assignment. So I am sure all of you are ready with it. So let us go on to discuss it. The first problem goes like this. Is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 composite or prime? Explain. So we have already seen that if we have such problems, there will be some common factor. So what is a common factor here? Yes, 5 is the common factor. So let us simplify this and write it. So we can write this as 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 1. So this entire thing we have taken 5 as a common factor and simplified it. Now whatever is there within the brackets, we can simplify it and we get this as equal to 5 into 1009. So we have expressed the given number in the form of its prime factors, two prime factors. So if we are able to express this as a product of two primes, is it a composite or a prime number, children? Yes, it is a composite number. So we just write it as, since 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 can be expressed as product of two primes, it is a composite number. I'm sure all of you have got it right. So let us go on to the next problem. Show that 12 to the power cannot end with the digit 0 or 5 for any natural number n. 12 to the power n cannot end with the digit 0 or 5. So what do we do for that? We take this 12 to the power n and factorize it and then logically argue and say whether it can end with 0 or 5. Fine. So 12 to the power n can be written as 3 into 4 whole to the power n. 4 can further be written as 2 to the power 2. So this can be simplified further as 3 to the power n into 2 to the power 2n, which means that 2 is a factor of 12 to the power n. Since 2 is a factor of 12 to the power n, is 12 to the power even or odd, children? Yes, it is even. If it is even, can it end with the digit 5? It cannot end with the digit 5. So, 2 is a factor. It is an even number. So, the number cannot end with 5. That's all. So, since 2 is a factor, it is an even number. It implies that it is an even number and the number cannot end with 5. What about 0? It's an even number. But if it has to end with 0, it should be even. What are the conditions? It should be even and it should have 5 as a factor. Okay. So, is 5 a factor here? No. Only 3 and 2 are factors. So, we can say that 5 is not a factor though it is even and hence it cannot end with 0. Got it, children? I hope all of you have written it in the same manner. Let us go on to discuss the next one. 210 oranges, 252 apples, 294 pears are equally packed in cartons so that no fruit is left. What is the greatest number of cartons needed? So let us understand this problem. We have got 210 oranges, we have got 252 apples and 294 pears. Okay. All of them are packed in carton boxes and each carton box must have the same number of fruits. Okay. That means what is happening? What are we doing here? We are dividing each of these foods by a common factor. That means we need to find the HCF. So we write the prime factors of 210. So we get 7 into 3 into 2 into 5. Similarly, 252 can be written as, on further simplification, we get finally 3 squared into 7 into 2 squared. I'm sure all of you might get the same thing. Why? Yes. Fundamental theorem of arithmetic says that the final factors, when we put it into its prime factorization form, it is unique except for the order. Fine. Next, 294, you get it as 3 into 7 squared into 2. Fine. So what is the HCF? Something that is common for all this and the least power that we have already seen. So the HCF is 3 into 7, which is 21. So this means that each of the cotton boxes will have 21 fruits. That means what? There will be 21 oranges in each of the cotton boxes, 21 apples, 21 pears. Okay. So we have to find out now what is the greatest number of cartons needed. So 21 oranges can be there in one box. Okay, so how many boxes we need for oranges? Yes, 10. Okay, children. So number of fruits in each pack is 21. So for oranges we will require 10. For apples, 21 apples in one carton boxes. There are 252 apples. How many carton boxes we will require for apples? 12. And for pears, 14. We simply have to divide this 210 by 21, 252 by 21, 294 by 21. So these are the number of cotton boxes. So totally how many cotton boxes do we require? We have to simply add it and we get 36. Is it clear, children? Fine. Let us go on to the next one. We have a problem here which says that a certain number of students can be arranged in groups of 3, 4, 6 or 8. Okay. Find the number of students. Groups of 3. That means the entire student can be made into 3 groups. They can also be made into 4 groups. Or you can make them into 6 groups or 8 groups. So that means what? The given number is a common multiple for 3, 4, 6 and 8. Which means that we need to find the LCM of 3, 4, 6 and 8. So that is very easy. We know to write 3 is equal to 3 into 1, 4 equals 2 squared, 6 is equal to 2 into 3 and 8 is equal to 2 into 2 to the power 3. Okay. So the LCM is the highest power. Okay. So LCM is equal to 3 into 2 cube, which is 24. So number of students is 24. So this 24 can be arranged in 3 groups. At that time you will have 8 students each. You can make them into 4 groups with 6 students each, or you can make it to 6 groups with 4 students in each group, or you can make them into 8 groups with 3 students in each group. Okay, children. So I am sure you have got this answer also. And now let us proceed further to understand what we have to learn in today's class. So we have been studying about real numbers, and we know that real numbers consist of natural numbers, whole numbers, integers, rational and irrational numbers. So hitherto we were studying about the properties with respect to whole numbers. Okay, children. Now we will study about irrational numbers. That is, we already know what irrational numbers are, isn't it? So we are going to study about it again, and hence we are saying we will revisit irrational numbers. So before doing that, we will have to understand one small concept. Let us look into it. Consider 6. 6 can be written as 2 into 3. We know that. This means that what does the 6 equal to 2 into 3 indicate? 6 is divisible by 2 and 6 is also divisible by 3. 6 is divisible by 2 and 6 is divisible 3, or 2 divide 6. 3 divides 6. That is the meaning when we write 6 is equal to 2 into 3. Now, what is 6 squared, children? 6 squared is equal to 2 into 3 whole squared, which is nothing but 2 squared into 3 squared, isn't it? So, when you square the left hand side, you have to square the right hand side. So, this indicates that 2 divides 6 squared also, isn't it, children? And 3 divides 6 square also. So 2 divides 6 squared, also 3 divides 6 squared. That is the meaning of this. Let us take another example. Say 21 equal to 7 into 3. So what does this indicate? 7 divides 21 and 3 also divides 21. That is the meaning of this. 21 equal to 7 into 3. Now what about 21 squared is equal to 7 squared into 3 squared? What does this mean? This means that 21 squared can be divided by 7 and 3. Isn't it? So 7 divides 21 squared. Also 3 divides 21 squared. I hope this is clear. Okay. So we have just taken a few examples. In general, suppose we consider, say, some number A equal to P into P1 into P2 into P3 into etc. Okay. So what does this statement indicate? This indicates that P divides A, P1 divides A, P2 divides A, and so on. Isn't it? So A equal to P into P1 into P2 into P3 into etc. indicates that P divides A, P1 divides A, P2 divides A, and so on. That is the meaning of this statement. This we have already understood. Okay. Now, what is A squared? A squared is squaring all this. P squared into P1 squared into P2 squared into etc. Whatever it is. So, what does this indicate? Again, this tells us that P divides A squared. P1 divides A squared. P2 divides A squared and so on. So, in general, we can say that if we have A is equal to P into P1 into P2 into P3 into etc. If P divides A, P also divides A squared. We have taken P in general, it could mean any of this. Okay, children, in general, if we have any statements such that A is equal to P into P1 into P2 into etc. some number. So it means that this P divides A, which also means that the same P divides A squared. We have taken P in general. It could be P1, P2, anything. Is it clear, children? Fine. So we will be using this concept in our further understanding. Clear? Very simple. You should just know that if A is equal to M into N into etc. Okay. That is M divides A, M also divides A squared. That is all. Is it clear, children? Fine. So let us do something what we have to do in today's video. We are asked to prove that root 2 is irrational. Irrational means what? It cannot be expressed of the form P by Q. Okay. The method that we use is called as the method of contradiction. Let us understand what is this method of contradiction with a small example. Say there is a child. This child knows about the characteristic of an elephant. That it has got a long trunk, it has got tusks, it has got big ears. These are the attributes that the child knows. Okay. Now, suppose we place this picture in front of the child and ask, is this an elephant? What will the child do? The child will think about all the characteristics of the elephant. So, it will find out if this picture has got a trunk. This does not have a trunk. Does it have a tusk? It does not have a tusk. Does it have large ears? It does not have large ears. So, the child will come to a conclusion that it is not an elephant. The child does not know what this picture is, but the child can come to the conclusion that this is not an elephant because the child knows about the characteristics of an elephant. How did the child do this? By the method of contradiction. So it is contradicting the characteristic of this monkey that the child sees is contradicting the characteristics of an elephant. So by this method of contradiction, the child concludes that this is not an elephant. Is it clear, children? We also use this technique to find out if root 2 is rational or irrational. We have to prove that root 2 is irrational. That means what? Root 2 cannot be expressed of the form P by Q. So we are going to use the method of contradiction. So what are we going to assume? We are going to assume that root 2 is rational. Okay, just as the child assumed that the picture shown is an elephant and then started seeing if the characteristics of elephant are present in that. So also we are going to assume that root 2 is rational. That means we are going to see if the characteristic of a rational number is present in this. If it is not present, then we say it is irrational. Just as the child found that the characteristic of elephant is not present and he said that this picture shown is not an elephant. Is it clear, children? So if root 2 is rational, then how can we write root 2 as? Yes, we can write root 2 as equal to P by Q and we assume that Q is not equal to 0, P and Q are co-primes, which means that P by Q, it is in the simplest form for root 2. P and Q are co-primes means that there are no common factor other than 1. They need not be primes themselves. They may be prime or prime and composite. One can be prime and one can be composite also. Okay. So for example, 4 by 7. 4 is not a prime number, but they do not have any common factor. So also 4 by 9. Neither is 4 prime nor 9, but they do not have any common factor other than 1. Okay, so such numbers are called as co-primes. So we assume that P and Q are co-primes, which means that there are no common factors for P and Q. Okay, children. So now let us simplify this. So we get P is equal to root 2 into Q. On squaring, since we don't want root 2, we will square it. We get P squared is equal to 2Q. If P squared is equal to 2Q, this means that 2 divides P squared. If 2 divides P squared, it also should also divide P. Just now we have seen if A is divided by P, A squared is also divided by P. The reverse is if P divides A squared, P also divides A. We use that concept here. P squared is equal to 2Q implies that 2 divides P. That means we can write P as the form 2 into something. Isn't it? 2 divides P means what? We can write P is equal to 2 into something. We write P is equal to 2 into R. So, we have arrived at a result that 2 divides P. So, let us call this 2 divides P as equation 1 or statement 1. Okay. Now, we have arrived at the result that P is equal to 2R. But what is P equal to? Root 2 into Q. So, we will substitute P as 2R in this equation. Okay. But P is equal to root 2 into Q, which means that 2R is equal to root 2 into Q. We will square both the sides. We have 4r squared is equal to 2q. Or on simplifying, we have 2r squared is equal to q. What does this statement mean? This statement means that 2 divides q. Is it clear, children? So we have got that 2 divides q. Let us call this as statement 2. See, we have got two statements. 2 is dividing P and 2 is dividing Q. So comparing these two statements, we can find out that we can understand that 2 is dividing both P and Q. But what is our assumption? P and Q are co-primes. That means there is no other factor other than 1. Okay. So this means that from 1 and 2, we can say that 2 divides both P and Q. 2 is a factor of both P and Q, which contradicts the statement that P and Q are co-primes. Why did this contradiction appear? Since we assumed that root 2 is rational. Okay. Since we assumed root 2 is rational, we then wrote root 2 is equal to P by Q. Okay, and we assume that P and Q are co-primes. But we have come to a conclusion that P and Q are not co-primes. That means there is a common factor. That happened because we assumed root 2 to be rational. Okay, so our assumption that root 2 is rational is wrong. So root 2 is irrational. Is it clear, children? Very simple. These problems are very important. Please understand the concept. Don't write it so many times. Okay. We start with root 2 to be rational. If it is rational, we know that it can be expressed of the form P by Q. Q not equal to 0, and we put a condition that P and Q are co-primes. You just simplify it. You get 2 divides P. Call that as statement 1. Then that, which means that P is equal to 2R. Substitute for P equal to 2R in whatever you have started with. You get 2R squared is equal to Q, which means that 2 is divides Q. So from these two, you know that 2 is dividing both P and Q. That's all. So this means that 2 is a factor of both P and Q, which is contradicting our assumption. And that is because we assume that root 2 is rational, which is wrong. Hence, root 2 is irrational. That's all. Is it clear, children? You do the same thing for root 2, root 3, root 5, root 7. Everywhere it is the same procedure. Let us do one more problem. We'll now prove that root 3 is irrational. We proceed on the same grounds. So, we considered root 3 to be rational. Okay. So, if root 3 is rational, we know we can write it as a form P by Q. So, root 3 is equal to P by Q. Q not equal to 0. P and Q are co-primes. The same statement. Now, we simplify this. And we get P is equal to root 3 into Q, which means P squared is equal to 3Q. P squared equal to 3Q means 3 divides P squared. So, 3 also divides P. Okay. So, we call this statement as statement 1. If 3 divides P, then we can write P is equal to 3 into something. We write P is equal to 3 into R. But we know what P is. What is P? P is equal to root 3 into Q. So, we consider P is equal to root 3 into Q. Substitute for P as 3R. So, 3R is equal to root 3 into Q. On squaring, we have 9R squared is equal to 3Q. And on simplification, we have 3R squared is equal to Q, which means that 3 divides Q. Let us call this as statement 2. So, statement 1 we have 3 divides P. Statement 2 we have 3 divides Q. This is what we have to establish, children. Okay. So, comparing, the rest is just you have to write down what you have understood. Comparing 1 and 2, we have 3 divides both P and Q. 3 is a factor of P and Q, which contradicts the statement that P and Q are co-primes. So, our assumption that root 3 is rational is wrong. So, root 3 is irrational. That's all. So, if you are asked to prove that root 5 is irrational, what will you do? You will do the same thing. you will consider root phi to be rational. Root phi can be written on the form P by Q. So that means P is equal to root phi into Q. So you will get that phi divides both P and Q. If it is root 7, you will arrive at 7 divides both P and Q. That's all. Okay. So which is contradicting to our assumption, and so the given number is not rational. It is irrational. This is how you conclude. Okay. So this is about such numbers. Okay. Sometimes you will have, we will now prove that 5 minus root 3 is irrational. So as usual, we consider 5 minus root 3 to be rational. So if 5 minus root 3 is rational, we can express it of the form some P by Q. Okay, we are considering it as A by B, anything. So 5 minus root 3 is equal to A by B, B not equal to 0. A and B are co-primes. This is the standard condition that we consider. Now we have to find out the value of root 3 in terms of all these. That means we are going to simplify this. So we have root 3 equal to 5 minus A by B, or on further simplification we have root 3 equal to 5b minus a by b. Okay. So here we know a and b are integers. So 5b minus a will also be an integer, and b is already an integer. So we have got this of the form P by Q, where P and Q are integers. We have already specified b not equal to 0. That means what? Root 3 is a rational number. Okay, since a and b are integers, we have this to be rational. So this implies that root 3 is rational. But we have already proved that root 3 is irrational. So this is the aspect that we consider for proving this. Okay, children. So this is very easy. Just simplify it. You get a rational quantity. So you will say that root 3 is irrational. But we already proved that root 3 is irrational. So why did this contradict come? Yes, that is because we considered 5 minus root 3 to be rational. So it implies that 5 minus root 3 is irrational. That's all. As simple as that. Okay. Shall we do one more? Let us now prove that 3 root 2 is irrational. So we follow the same steps. So what do we consider? Let 3 root 2 be rational. So if 3 root 2 is rational, we can express it of the form a by b. So we write 3, let 3 root 2 equal to a by b, b not equal to 0, a and b are co-primes. So simplify and find the value of root 2. So we have root 2 is equal to a by 3b. So again we know that a is an integer and 3b is also an integer. So a by 3b becomes a rational number, and we have already considered b not equal to 0. So this means that root 2 is rational, but we have already proved that root 2 is irrational. So our assumption that 3 root 2 is rational is wrong. Hence 3 root 2 is an irrational number. So when you are asked to prove only root 2, only root 3, only root 5, children, you will use the other method. Suppose you have any addition or subtraction, multiplication, division along with these already proved that we have already proved all these to be irrational. With that, then you will follow this method. Is it clear, children? Okay. So what have we learned in today's video? We have understood that if P divides A, P divides A squared, or if P divides A squared, P divides A. So we have used this concept to prove that root 2 is irrational, root 3 is irrational, 5 minus root 3 is irrational, and 3 into root 2 is irrational. We have seen that for root 2 and root 3 to prove it is irrational, we have got one particular pattern, and to prove that 5 minus root 3 and 3 into root 2 is irrational, we have got a different pattern. Okay, children, please go through the video and understand these concepts well, and then please practice it. Okay, so these problems are very important. One of these will appear for their examination. So I have got an assignment as well for you. As usual, I have an assignment for you. Prove that root phi is irrational. Prove that 1 over root 3 is irrational. So thank you for watching this video. We will meet soon with the next video. If you have any doubts, please put them into the comment section, and please don't forget to subscribe, like and share the video. Thank you once again.